Good morning, dear students. My name is Ferhan Mazher, and today is the 16th of May 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O levels of physics, and today we are going to discuss the learner's guide. This is from the for the examination from 2016 to 2022, and this is the second part. In my first part that is already uploaded in the my YouTube channel. You can watch that. This is the part B, and we will do more parts on it until this document is completed. It's a very important document. Before you sit in the exam, in the actual exam, you need to read this. So let's start today. Today we are going to start from the fifth topic, and let me show you. So we are talking about the learner's guide, and so we are on the fifth topic. And the fifth topic is, yeah, here we go. This is the document actually. Okay, so if you have any comments, you can write here. So, okay, we have reached up to topic number 5, and the topic number 5 is moments. So the first thing you should understand is describe the moment of a force in terms of its turning effect. So when you apply force on a body which is pivoted on a pivot, so what happens? The body starts rotating about that point. This is called the turning effect. This is called the moment. And the moment is basically the force multiply the moment arm. So what is moment arm? Moment arm is the perpendicular distance between the line of action of the force and the force itself. So describe the moment of a force in terms of its turning effect. So when you apply a force on a body and the body starts rotating, we call it the moment or the turning effect, or we also use the word torque for this. Describe simple everyday examples of the moments. For example, when you open the door, when you close the door, you apply force. The hinge of the door is the pivot. That's a good example for the you applied the force and the body rotates about its axis or about its hinge. Where, for example, you open the door of the refrigerator and you close it, or uh, there were other examples. For example, the wheelbarrow example is very important. In the wheelbarrow, you apply the force on the handles in the upward direction. The load is in the middle, and the wheel of the wheelbarrow is the pivot. So that these are few good examples. And for example, if you are on a plank or on a rod, so we have a pivot, and your weight will be producing the turning effect. So many examples in everyday examples. If you have done the papers, you must have seen that there are so many daily examples on the moments. So the moment, you should understand, whenever you see an example of the moment, you should be able to recognize that where is the pivot and about which the body will rotate. And then wherever, whether it's weight or you have applied the force, you should understand what is the line of action of the force. And then you should understand the perpendicular distance between the pivot and the line of action of the force. So if you know that, put a tick here. State the principle of moment for a body in equilibrium. So principle of moment is very simple, that whenever a body is in equilibrium, all the sum of the moments acting on it will be zero. It means that the sum of the clockwise moments and the sum of the anti-clockwise moments will be equals to zero. That's the principle of the moments. Principle of the moments for a body in equilibrium, that the sum of the equilibriums remains zero. So you should understand that the moment of a force is equals to the force multiplied the perpendicular distance from the pivot. It's very important. It's not just the distance between the force where the force is applied and the pivot. No, you have to draw a line of action of the force, and then you have to find out the perpendicular distance between the pivot and the line of action of the force. So it's a very important formula. You should never forget this. And do calculation using a principle of moments. And you know this principle of moments is used in lot of numericals which come in the Cambridge exam. You always use clockwise moment is equals to the anti-clockwise moment. And whenever, for example, a very famous question is that we have a rod, and in the center of the rod, we put a pivot, and on the left hand and the right hand, we put masses or weights or loads. And there we use anti-clockwise moment, and clockwise moment is equal to each other. And from that idea, from the principle of moments, you find sometimes, for example, one weight is given, its distance is given, the other weight's distance is given from the pivot, but its weight is not given. So you can find that weight. But sometimes what happens, they show forces. So when they show a force, then it's very important to actually decide that by applying this force, clockwise moment is produced or an anti-clockwise moment is produced. For example, if this is the pivot here and I apply force upward, so what will happen from where I am looking, it's a clockwise moment. So I applied force on the left side. Okay. So if I apply force on the left side in upward direction, it produces a clockwise moment. But if I apply on the left side of the pivot a downward force, it will produce an anti-clockwise moment. So if the forces are shown there, don't be preoccupied that if it is on the left side or it is on the right side, the moment produced will be clockwise or anti-clockwise. No, you have to be very careful that when the force is applied on the left side or on the right side, you have to check it that if the force is in the upward direction or in the downward direction. And according to that, by using common sense, you have to decide that this force will make it turn clockwise or anti-clockwise. Okay. So it is very important for, especially when the forces are shown on a rod, and that this force will produce clockwise or anti-clockwise. Intentionally, you have to decide this. Okay. So this experiment has came many times, describe how to verify the principle of moments. Many times this has came in paper, that you have to describe an experiment in which you prove that the principle of moments. Okay. So what we do, we take a rod, and in the middle of the rod we put a pivot. We take two different loads. The loads we already know, and we hang them. One is on the right side of the pivot, the other is on the left side of the pivot, and we move them. And we move them until we get a point where the rod is balanced. Once the rod is balanced, then we check what is the weight one's distance from the pivot, what is the distance of the weight two from the pivot. Let's say that distance is d1, this distance is d2. Then we see that the product of the w1 and the d1 is equal to the product of the w2 and the d2. So this proves that when the clockwise moment and the anti-clockwise moment, the thing will be balanced. So this is a very famous experiment. Many times it has came in Cambridge exams. Okay. So another very important is the center of the mass. The center of the mass, first thing, the center of the mass is a point in the body where all the mass seems to be concentrated. And in our course, the center of the mass will also have the same as the center of gravity. So center of the mass or the center of the gravity. Center of gravity is a point in the body or outside the body, from where if you support the body, the whole weight of the body will be supported. And so it appears that all the weight of the body is acting at that point. So that point is known as the center of gravity, center of mass. Here, the one point the Cambridge wants you to know, and you should be able to describe that how to find the position of the center of the mass of a plane lamina. And you remember that experiment in which you have a irregular lamina, you drill holes in on different corners of that lamina, and then you hang the lamina from by a nail held in a retort stand by a pin, and you use a plumb line and you hang the plumb line coinciding with the nail, and along the thread of the plumb line you draw a line on the lamina. Then you do the same process by hanging the lamina with the other hole on the on that lamina. Then you do it with the third hole, and where the lines which you have drawn on the lamina along the thread of the plumb line intersect each other, that is the center of the mass. So this question also has came many times in the Cambridge exam. So you should be able to describe and write that experiment. So if you are able to do this, put a tick here. Then we have the stability, describe in words to find the position of the center of the mass of an. So describe in words the effect of the position of the center of mass on the stability of the simple objects. Remember, if the center of the mass center of the mass is lower, the body will be very stable. If the center of the mass goes higher, the body becomes unstable, or you can say less stable. So you should understand the relationship between the stability and the position of the center of the mass. Stability also depends upon on the area of the base. So, and another very important point in the stability question is that whenever a figure is given to you, for example, you remember that very famous figure of a tractor, and another question was of a bus which was tilted, and you have to decide that this will fall or not fall. So if you know the center of the mass, from the center of the mass, draw a vertical line exactly downward, which show the line of action of the weight. If the line of action of the weight is inside the base of the body will not tilt, the body will not topple. And if the line of action of the weight is out of the base of the body is going to fall in that direction. Okay, so whenever you disturb a body, so we always check that when you disturb the body, obviously the center of the mass will change, not means with the fact with the reference of the surrounding, its position will be changed. And the important thing in whether the body will fall or not fall, that depends upon the line of action of the weight. So wherever is the body, wherever is the center of mass, from there draw a vertical line downward. And if that line of action of the weight comes out of the base, the body will fall in that direction. Okay, so this idea is also very important. So this is stability. And another very important thing about the stability is that there were three kinds of stability: neutral stability, and you see, neutral stability was that if you disturb the body, the center of the mass neither goes higher nor goes down. So that's the neutral stability. And you should understand the stability and the types of stability that's in your textbook. Okay. The next topic is topic number 6. It is deformation. So, and the first thing is state that a force may produce a change in size and shape of a body. So you see, whenever I apply a force, so you see, whenever I apply a force, what happens? The force can change the size and the shape of the body. For example, when you apply a force on a body, so the length of that body will change. For example, if you stretch a body. Okay? For example, you have a spring and you stretch it. So when you stretch it, the length will change. So it means that the size of the body has changed, and the shape of the body will also change. But normally you see what happens when you do this and you do not cross. There are some limits, we will discuss that. but when you release it, the body comes back to its original shape. So this is called deformation, and the length, the change in the length which is produced, and that is called extension. So whenever you apply force on a body, uh, the length, in our course we have length, so the length will change. Okay, so the change in length is known as extension. So the length of the body before the before applying the force or load, and that is known as unstretched length. Unstretched length, that is represented with the L, L naught. And the when you have applied the force and the length of the body, the whatever the new length of the body will be after applying the load or the force, that is known as stretched length. That is now represented with the small l. And the difference between the L minus L naught, that is extension. We call that extension. Okay, so this chapter we have extension is very important. So the one first point, the force can change the size and the shape of the body. Plot and use extension load graphs for an elastic body. Okay, so the graph is very important. In that graph, extension load graph, on the y-axis we have extension, and on the x-axis we have load. So load means weight, or the load means the weight you have applied. And on the y-axis, we normally represent extension. So extension. So the extension load graph, on the y-axis we have extension, and on the y-axis, on the x-axis we have load, weight, or force. Okay. So whenever you plot this graph, you will observe in our course normally what happens. The extension and the load, they are directly proportional to each other. If two quantities are directly proportional to each other, their graph is always has a positive gradient. It's a straight line and it passes from the origin. So it's a very important shape of the graph should be a straight line whose gradient is constant and it passes from the origin. Okay, so normally in questions this graph is given, and you have to find out what is the, on certain extension, what is the length, what is the load, sorry, and or for this load what is the extension. So you should understand the extension load graph and how to use it in your questions. And another very important thing is that okay, so describe an experiment to measure the extension produced by different loads for an elastic solid. So you can describe an experiment. For example, you take a spring, you find its unstretched length and knot, then you hang, let's say, 1 Newton weight on it. You note what is the length, and then you use the formula extension is equal to L minus L naught, and you note down the extension. And then you put 2 Newton load, you note down what is the length now, L2, and you subtract L2 minus L naught, and you find the extension. Then you put 3 Newton load, you note down what is the length of the spring right now, and L3 minus L naught, that gives you the extension for that load. And in this way, you hang known loads and you note down the length, and by using that formula, extension is equal to stretched length minus the unstretched length. And then you plot the graph. On the y-axis, you take extension, on the x-axis, you take load, and by plotting the points, you will be able to draw the extension load graph. And I have told you that normally the extension load graph is a straight line which passes through the origin. So then is know what is meant by the limit of proportionality for an elastic solid. Limit of proportionality means that on the extension load graph, the point up to which the graph is a straight line. And if you cross that point, if you increase the load beyond that limit, what happens? The extension and then the load, they are no more directly proportional to each other. The extension load graph do not remain a straight line. it starts curving in the upward direction if the extension is on the y-axis. So when it starts curving, it means that uh, the load and the extension, they are no more directly proportional to each other. It means that the extension has become easier. Now it has become easy to extend that. Okay, so you should understand limit of proportionality, and you should able to be you should able to recognize the limit of proportionality on a given extension load graph. And sometimes you have to draw a graph that if you cross the limit of proportionality, what will be the shape of the graph. In that case, it is very important to understand that extension is where and the load is where. Normally, the extension is on the y-axis and the load is on the, extension is on the y-axis and the load is on the x-axis. So it will start curving in the upward direction. But if the extension is in the x-axis and the load is on the y-axis, then you have to think that it will not curve upward. So calculate the extension for an elastic solid using extension is directly proportional to the load. So it's a very important relationship you can use. You have learned in your mathematics the method of proportionality. If two things are directly proportional to each other, so you can use that formula. Another very important thing is in the elastic deformation is the case of springs. For example, if you hang a load with a spring and a certain extension, let's say suppose if I hang 2 Newton load with a spring and the extension produces 4 centimeters, for example, it is 4 centimeters. Now, if you take 2 springs, identical springs, and you hang them parallel to each other like this, if you hang them parallel to each other, and with them you hang that load, now the load will be distributed. Each spring will experience half the load. Now the extension produced in each spring will be only 2 centimeters because the load experienced by each spring will be half, because you have taken 2 springs, put them parallel, and then hung that load with them. But if you hang 2 identical springs in series, you put 1 spring and then below that you hang with the first spring, you hang the second spring, then the extension produced, and you hang that 2 Newton load, so the extension in both of them will be produced. And the spring which is in the second position, in the lower position, in that a 4 centimeter extension will be produced, and the spring which is above that, in that, due to that 2 Newton weight, the 4 centimeter extension will be produced, plus it will be supporting the weight of that lower spring. So the extension produced will become at least 8 centimeters. So this example is very important. Frequently he asks this question: a single spring, that two identical springs or 3 identical springs hung parallel to each other, or another example can be 2 springs hung with each other, directly with each other. So you should be very careful. If you have done questions on this type of questions, always keep them in your mind. Okay, so after this the topic pressure is we will start. So my dear students, in this video, in the B part, we have discussed two topics, and topic 5, turning effect of forces, and the topic number 6, that's the deformation. So I will come back with my C part of this lecture, and we will discuss more on the syllabus of our physics. So thank you very much, everyone, and I hope you have enjoyed this session. So if you have enjoyed this and you think that is informative, please share this video with your friends and with your junior students and all the students who are appearing for the Cambridge exam. Also share the link of this video onto your Facebook, Twitter accounts, and Instagram. So it's a great blessing for me to be able to help you online through this YouTube channel. Keep praying for me. Thank you very much. Have a good day. God bless you all.